Hey everyone, Roland this side. I hope you all are doing well. So let's say the problem of the day.
So the problem number is 2492, minimum is score of path between two cities. So basically we are given a 2D array, and basically we are given an undirected undirected weighted graph. Okay. So basically we are given an undirected weighted graph. So here what we have to do is we have to return the minimum distance of road between, minimum distance the while we are traversing from. So look what the problem says is that indicates the distance by direction road. So basically we are given a matrix road, okay, where this represents there exists a road between A and B of distance d, which is undirected. Okay, we can traverse forward and backward in both directions. The score of path between the two distance is defined as the minimum distance of the road in the path. So score of a path, okay, so for example, if we take this path, so score of this path defined as the minimum of the minimum edge width of this path, okay. So the minimum distance of a road in this path. So what is the minimum distance road? It's 7. Okay. For in this, okay, for in this path the minimum is 6. For in this path the minimum is 5. Okay. So the score of a path is the minimum width of that path. Okay. Minimum width across the whole path. Okay. Return the minimum possible scores of a path between city 1 and end. Okay, so between city 1 and end, and is here we have 4. So between 1 is 4, we have to return the minimum path. Okay, so first if you see here, you might think, for example, you might think from 1 and 4 the minimum path is 7. Okay, but if you see it's undirected. Okay, so we can traverse forward and backward. So we can go to 2, we can go to, I mean we can go to 2, we can go to 4. Okay, so while going to 2 to 4, the minimum we got is 5. Okay, so there isn't mentioned that we have to choose the number of times we can take, so we can hop any number of times. So by hopping this we got the minimum as 5, and we have to return the lowest. Okay, so we have to return the minimum possible. Okay, so minimum is 5. So basically what we have to do is in a graph, in an undirected graph, if you see, if you have to reach any node, okay, for example, I have to reach one this node, and its weights goes like 1 2 3 4 5. So simply what you can do is you can go to this and come from this and then again go to this, so the minimum become is 1. So for an undirected weighted graph, if we have to calculate the minimum, minimum road distance to visit from any to anywhere. Okay, so what, in other words, what basically asking it, it's asking us to give the minimum edge width across whole graph. Okay, so across whole graph we have to get the minimum edge width. Okay, so to get the minimum edge width, what we are going to do is simply we can do a BFS, and while doing the BFS we can track a variable called min score, and it's keep updating minimum of the current edge weight. Okay, the current weight, uh yeah, the current weight comma min score. Okay, while doing the BFS. So to do the BFS we can, in slash and adjacency list. Okay, so it's a vector int and visited. So that's how we are not going to end up visiting twice. Okay, a visited array, and okay, and a simple queue, and queue dot post. We have to first queue and queue dot post 0 visited 0 equal to true. Okay, and after that, while queue isn't empty, we are keep traversing our adjacency list. Okay, for auto, neighbor or adjacency list. So from each neighbor, what we are going to do is look, for each neighbor v and d. So we are going to get the, okay, for example, first of all we have to create the adjacency list, call it roads, an adjacency list. We are extracting from road and we are going to push back A to D. So there exists a path within A and D, and there exists a path from A to B and from B to A. Okay, we are going to push that. Okay, and after pushing that, we are going to push that in pair, and then what is the weight of that path? Okay, so we are also taking the weight of that path. Okay, and after start visiting array. So mark everyone as false, visited a q dot post and a simple VFS. So let's pop out the front, take the U and the visit every V for every neighbor for V and calculate the distance. We are get the minimum distance, and if V is not visited, push V in Q and okay, and keep iterating it until it's Q becomes empty. Okay, and at last return the minimum distance. Okay, and if you see the time complexity, we are visiting only once because due to its visited array, we are not end up visiting any node twice. Okay, so the time complexity become big of n. Okay, and the space complexity also become big of n because we are using an adjacency list. Okay, so time complexity equal to big of and space complexity are we are also using as big of n. Okay, it can go to 2 or 3, I think. Let me check. For q it can go to 2, for visited 1, 2 and 3. Okay, so it can go up to 3n, which is as good as big of n. Okay, so I think yeah, that's the space complexity and time complexity for this problem. It's kind of one of the easiest problem in a graph where we have to do the simple BFS. Okay, so I think yeah, that's it for today. I hope you like this video, so please make sure to subscribe to TENZOR and feel free to ask any doubts if you have any comments. Till then, keep smiling and keep coding.